Good afternoon, everybody. Thank you, VB team, for this opportunity, and thank you, everyone, for coming to this talk. I couldn't be there in person, but I have some very exciting research I want to share with you. The talk is titled Malicious GenAI Chrome Extensions, Unpacking Data Exfiltration and Malicious Behaviors. I'm Shresta. I'm with Palo Alto Networks. I've been working at the web security team over the past 5 years. We specialize on protecting customers from enterprise customers from web-based threats. My interests are malicious JavaScript detection, compromised website detection, and more recently, browser extension security, which this talk is close to. And my LinkedIn and Twitter handles are here, where I post more frequent updates on some of the research findings. These are my co-authors, Nabil and Billy. They are also my colleagues at Palo Alto, and here are their contact information. So please feel free to reach out to them as well for questions. I want to kick things off by highlighting 3 browser extension threats you will see today. The first one is the browser adversary in the browser attack, which is something we reported last month via the Unit 42 handle. The second threat is something that uses the impersonation technique, and this was reported as part of a broader campaign by Domain Tools in May. And the third threat that we'll be looking at is prompt hijacking, which is going to be reported in the Unit 42 channel this week. So the high-level agenda of the things that we'll be talking about is the GenAI in the browser extension space. The fact that the demand for GenAI features is disrupting the extension landscape. And most of the talk will be about the attacker tactics in the browser extension. So we'll deep dive into some of the malicious extensions, over 150 extensions that we found in the last few months. And the threads that they were spanning into 2 broad buckets: data exfiltration and malicious redirections. So we will go over some of the techniques that were used in these extensions. And before we deep dive, I will also go over browser extensions in general, give a refresher so that the attacker tactics kind of make sense. All right. So the first part of this talk is the demand for GenAI features is shifting the browser extension landscape. So if you look at the graphic here, it is my caption for Gemini, where I said GenAI Express pulls into the extension station, and that's what I got as a nice introduction to GenAI related stuff. But anyway, I wanted to highlight one key stat is that from this market.us report, we see that for the next 10 years, the AI browser market is probably going to expand at grow at 33% CAGR. And this not only applies to the browsers, it also applies to the extension space. So this growth, as we see, might be from the user's requirement or the desire to increase their productivity with AI features. One key stat from the Google SEO shows a 900% increase in the keywords called the Google extension AI keyword, a 900% increase year over year, where users are actually searching for such extensions. So that's the demand side of things, and with demand comes supply. And if you look at the Chrome Web Store, there is a specific page where it features all the AI-powered extensions. Some of them are extensions you might be familiar with, and there are hundreds of such AI extensions that are launched each week. And we were looking at the AI summarizing category. So let's say there is an extension that takes content from a web page and it summarizes into, let's say, a pop-up. So for those kind of features, we are also seeing almost a drastic increase into the AI summarizing Chrome extensions category. So what we just saw was that the demand and supply is high, and it's projected to grow in the future as well. And having said that, I want to dive a little bit into the browser extensions itself, the architecture, and what exactly browser extensions are, so that the deep dive section will hopefully make a lot more sense. Okay, so what are browser extensions? Um, okay, so the browser extensions are software add-ons that extend the functionality of the browser. Uh, Typically, browser extensions are built with HTML, CSS, and JavaScript. And if you look at this, some of the extensions that I've installed, I have like Grammarly. So it's a nice example where when I type something, I use Grammarly to proofread. So that gives a illustration of how my web searching experience is improved by this browser extension, Grammarly, or maybe even Zoom. I just want to clarify that I will be talking about extensions from only the Chrome store, as opposed to side-loaded extensions or custom extensions where the attack vector or the threat model could be different. Um, and just even if we talk just about the extensions in the Chrome Web Store, there are lots of extensions used by lots of people. So one study estimates that about 200, almost 180,000 extensions are in the Chrome Store, and each of these extensions get updated like tens of times a month. So if for a security a researcher or analyst, this is a lot of extensions to be analyzing constantly. And typically, user has 8 to 12 extensions installed on average. So, so far, we clarified the volume of these new extensions. Now, let's look at the architecture overview of an extension. So a browser extension has 5 key components. The 5 components are listed in this, and let's go one at a time. The first one is a service worker, and from the manifest v2 world, it's called background script. And what a service worker does is it runs in the background of the browser, and it runs the core events and the core extension logic in the background, as opposed to the content script. The content script is something that is injected or embedded into the page, and this has access to the DOM. It can read and write the DOM based on the settings or the permission requests of the extension developer. The third part is the pop-up. So the pop-up, if you look at this, I have a pop-up here. So pop-up is this orange square represented in the figure. It has some functionalities that could be to do with like configuring the extension, or it could do a lot more, but it doesn't really have full access to the DOM, but there is more logic that can be added into that, and as we'll see later in the talk, there are threat vectors that come from the pop-up as well. The fourth part is the manifest.json. Manifest is like the config file. It's a mandatory file, part of the extension, and it contains permissions, scripts, behaviors that the extension would do. So this is key for someone vetting the extension as benign, or a user who is a researcher who's evaluating an extension, and the extension developer. So this is the key file. And the last part is the CRX file format that is used. That's the format that is used to package extensions and distribute it. I want to show the UI elements of the extension. Sure, why? Oh, yeah. So the extension typically in the UI, if you look at this Microsoft single sign-on extension, all the parts that we spoke about are on the screen. So there is a 32-digit unique extension ID. It's the alphanumeric, which is used to maybe have policies on the extension, and this is the pop-up, and this is kind of the UI elements when you're just trying to analyze the extension or like install the extension and you interact with the Chrome Web Store. On the background, all the components that we spoke about for the Microsoft extension is shown here in this unpack CRX. And the most important file is the manifest file. And as I said, it has uh, the permissions. For example, in this case, it says it might access cookies, which is represented by the storage API. The native messaging, it says it might want to send messages to and from different parts of the extension. So in this case, the content script. And then there are more fine-tuned policies. For example, it tells the browser that the service worker logic is in the background.js file, which is this file. And here you see Microsoft has written some logic to listen to messages and maybe do something to do with single sign-on, which we will not dive deeper into. But then this is to show that the logic can be in different parts of the code. Um, the next part is the message passing functionality of the extension. So um, just like the key components, one of the main features that I want to highlight that is very critical to the understanding of the attacker tactics is the message passing between the content scripts and background scripts. The content script has access to the DOM. The background script runs with its own content security policies, and the message passing is the key here, where the attackers are able to send messages to the background and then exfiltrate. So let's just use this toy example to understand what's going on here. So in the content script, when every time a page is loaded, this specific toy extension sends a message to the background script saying hello, and the background script responds back saying message received. So this is just to demonstrate message passing, and the manifest file has a lot of permissions configured for this to happen. But if at a very broad scale, this is like an exaggerated example of all the permissions that you could give for an extension. So if you look at the browser, the permission list, this is pretty much an exhaustive list of all the possible APIs that the Chrome offers. So this is like a really broadly permissioned extension. And then here it says the host permission is all URLs. This means the background script can communicate with any resource on the internet. And it says the content script should be injected into all URLs, which means all the URLs that the user of the browser is visiting, the content script is injected into. And then it's also saying the extension can execute JavaScript from any domain. So this is the example of all these parts combined can give the attacker the most broad permissions. However, in real life, the user gets a display of all the permissions. So it's typically unlikely that there is such broad abuse, but this is just an exaggerated example to show that the permissions can be really broad. And attackers do have such permissions where they do get permissions granted, as we'll see in the examples in the future. Okay, so now that we have understanding of browser extensions, it's time to look at the um, attacker tactics. And the first specific broad category is called data exfiltration. It's the adversary in the browser. And here is the setup. So there is an employee, Frank, who is reporting to VP Sarah. And this is a case where the browser extension is the adversary that's installed in Frank's machine, in this case, the laptop. So Frank is looking to improve his productivity. He comes across this supersonic AI extension, which has great ratings. Um, and he sees that there are some nice features. It can generate replies as soon as it gets the email, just by the click of a button, and it can do email summaries. So seems super useful for Frank. So he goes ahead and installs, and right after the extension is installed, Frank gets a confidential message from his boss Sarah that there is some contract terms about a company called ZebraWorks that's going to be acquired, and they're supposed to be confidential and should not be forwarded to anybody outside their group. Frank writes an email to assure that the information will be confidential, and uses supersonic AI extension in the process to craft the email. He clicks the generate email button. The supersonic AI extension gets the response email in the pop-up, which gets applied to the text backend, and this makes the communication for Frank easier. But in the backend, here's what is happening. So when Frank clicks the generate button, so this is the content script. It has access to the DOM. The click handler is there is a listener for the click handler, and then it opens a pop-up. At this point, the response has come from the API that the extension is using, and to get this response, it needs to send the email message. So if you look at this variable last email content, this is the email, or this is the content that seems to be going to the endpoint, and it is going via the background script. And as you see in the logic of the background script, it gets the generate the listener to listen to the message from the content script. In the response, it gets the email. The generate reply adds the email content to the payload here, and it sends to this. It does a XML fetch to the endpoint API.goSupersonic email. And if you look at the network logs in the sandbox, you can see that the HTTP response being request being sent with the email data. And it's not just that it's not that Frank has to interact with the extensions, buttons or functionalities. Just by having the extension installed in the background and never using it, there is an email summary that comes on the top. And if you look at what's happening, sure enough, Frank gets an email from LinkedIn about his OTP, and you see that it's just by having the email summary, the OTP goes to the attacker's endpoint. So the attacker has control of Frank's LinkedIn account. So uh, the extension is still live. It's not detected by most VT vendors. It has a weak signal, just one VT score. So it's not maybe enough to block by most of the security companies. So just something to think about here. Um, for each of the attacks, I'll add a link with a QR code that you can either scan or go check the Twitter handle for the list of IOCs or more such extensions and examples that I'll leave in the slide. So we looked at the adversary in the browser kind of data exfiltration technique. There are more techniques like impersonation and dual functionality and bait and switch that I'll cover in this example, and that will wrap the data exfiltration segment. So in this specific extension, we'll look at three tactics: impersonation. So the DeepSeek AI free AI assistant is, and also the Manus AI free assistant are impersonating two popular companies, DeepSeek and Manus. It's got a quite bit of installs, and the look and feel is modern, and more importantly, the original functionality is preserved, and that's the dual functionality where it's coming from. It was reported in the domain tools blog. The first time it was reported in May, so I'm using the same term here. The point is that the user is unaware of the data exfiltration because the functionality is preserved. There is an impersonation going on, and when the user has the extension installed, it actually communicates with the DeepSeek API and has the response that the user wants. So the user does not know the impersonation of the impersonation because the extension is working as expected. And if you look at the network logs, here you can see that there is one request that actually goes to DeepSeek, but then there is communication with the attacker's endpoint, in this case API dot glimmerbloop.top. So this is the second technique, which is dual functionality. But there is one more technique which I want to talk about, that was not probably covered by the initial research, and that is that there is also a bait and switch tactic being applied here. The extension launches two benign versions, and then the exfiltration endpoint is added. And just to make things a little more harder, there is some reobfuscation going on, and then the low reputed endpoint is seen at somewhere in a very big background script file. Maybe hard for if you're trying to manually evaluate it. But here is the endpoint that you see, and if you look at the diff with the previous version, that's when you actually notice the exfiltration endpoint being added. Okay, so that concludes the data exfiltration part, we spoke about how extensions and the Gen AI is kind of exploding, and the extension landscape is exploding. And then we spoke about data exfiltration as one of the attackers' tactics. Now let's talk about malicious redirect. And then the first one is prompt injection, that falls under this category. So let's say do you want to speed up your Perplexity chat search? You don't want to open the tab every single time. So you open this extension called Perplexity Search. Uh, the impersonation applies even here, because this is not actually from Perplexity Search, but if you look at the logo and the UI, it looks very much like this extension is from Perplexity. And these extensions are great vantage points for these prompt data collection. And search hijacking is kind of the predecessor to the prompt hijacking. And we have seen a lot of campaigns that do the same thing. Um, but the general idea is the user enters the search query or the string in the omnibox, and the prompt hijack works by actually sending the request to Perplexity. So the original functionality is there, so this also has a dual functionality, and the user gets the response. But then, similar to the previous case, we see that the data that is being exfiltrated is the search term. So here the prompt is being hijacked. There is also a redirection going on from first the request goes the attacker's domain and then to Perplexity. So this can potentially be abused on the server side to redirect the user to different destinations. That could be ads based on what the user has searched. That could give attacker the revenue from such hijacking. The second category that I want to talk about in malicious redirects is affiliate fraud. This is also a money making strategy for the attacker. And let me demonstrate this with this example, Photoroom AI editor. So if you look at this extension, it has quite a bit of installs. There are 600 installs, and the extension has such basic functionality. It says it's an AI photo editor, but then all it does is just two features. And the idea here for the extension is that as soon as the extension is installed, the attacker gets this deceptive page that says your Chrome version is not supported. So it opens it in a new tab, and the idea here is that there is an affiliate link from the attacker to install this different browser, Opera browser. And if you look into the background script source code, you can see that it abuses the chrome.runtime.onInstalled API that is fired as soon as the extension is installed by the browser. And this event triggers the tab create API, and there the attacker has the domain photo whatever extends.uno. And what this does is it redirects the user to this endpoint where the affiliate link is actually displayed. And if this user installs the browser, this leads to the attacker getting um, uh, affiliate commission, because it's like a paid advertising link. But it could be abused for more cases as well. So this is like affiliate fraud, which is one of the second cases of malicious redirect after prompt hijacking. And QR code with more details. And the third category here is the PUP delivery, which is part of the malicious redirect. But in this case, the redirection leads to a slightly more insidious payload, and that's called potentially unwanted program. So let's say the user is trying to modify the cursor, a mod extension, and the cursor maybe would look like a Pokemon or a Pokeball. The extension, first of all, packages a lot of cursors. In this specific case, there are 200 plus installs on the Pokemon cursor. But the idea here is that there is a link, embedded link, within the pop-up page called Get More Cursors. So the extension serves just as a way to get more traffic to the Grayware site, ovid.com, and that's done by having a lure of a few cursors in the extension, and then trying to send more traffic to this grayware domain, which has a lot of PUP. And if you look at when you visit the site, which is not very clear, but if you go here, this goes through a redirection chain where the attacker tries to socially engineer the user into installing the search safely extension, which is a gateway for more affiliate fraud and more such attacks. So this is also part of a broader campaign. We saw about 150 such extension, or maybe 100 such extensions that just helped modify the cursor. But then, if you look at the sum of all the user installs, it seems like the majority of the traffic seems to be targeted towards redirecting traffic to the attacker's domain. And that concludes my talk. I want to summarize the points that I spoke so far and reflect a little bit to close it out. So the first point that we covered was that there is a high demand and supply of GenAI extensions, as we saw in the Chrome Store example use case. The second part that we saw, that this rising AI feature demand in extensions is also a reason for abuse to exfiltrate sensitive user data such as emails and messages and user search queries. Some of the QR codes has examples where WhatsApp messages are exfiltrated. So there is quite a bit of a spectrum here. And the last point is that attackers abuse privileged features and APIs to perform malicious redirects for their benefit through affiliate fraud, or just expose the users to significant risks such as PUP and adware. So I want to give a huge shout out before I close my talk to my team at Palo Alto's Internet Security Research Team. All these people without which the research would have not been possible. And I want to thank you again for listening to my talk. And if you have any questions, please reach out to me on my email or LinkedIn or Twitter. And thank you all.